Okay, let's discuss limit of a function. So given a function f of x, let a and l be real numbers. So look at the graph. As x gets closer to a, but not equal to a, so the corresponding value of f of x get closer to L. So the value of f of x can be made as close to L as desired. So just choose a value of x close enough to a. So we say that L is the limit of a function f of x as x approaches a. So you read this as the limit of f of x equals to L as x approaches a. Take note that the limit definition just says what happens when x gets close to a. The function might not be defined at a. So here we have the following limit laws. In some books, these are called properties of limits. So first is the sum rule. The limit of f of x plus g of x equals L plus m as x approaches c. So given that the limit of f of x is equal to L as x approaches c, and the limit of g of x is equal to m as x approaches c. So there are two different functions, but same value of c. So difference rule, the limit of f of x minus g of x is equal to L minus m as x approaches c. For the constant multiple rule, so the limit of k times f of x is equal to k times L as x approaches c. For the product rule, the limit of f times x or f of x times g of x equals L times m as x approaches c. So this looks like the operation on function. For the quotient rule, the limit of f of x over g of x is equal to L over m as x approaches c, given that m is not equal to 0 to avoid undefined result. For the power rule, the limit of f of x to the n is equal to L to the n as x approaches c, given that n is a positive integer. For the root rule, the limit of nth root of f of x is equal to the nth root of L or L raised to 1 over n as x approaches c, given that n is a positive integer. So if n is even, we assume that the limit of f of x is equal to L greater than 0 as x approaches c. Now let's discuss continuity. For every value c of a function, there is no interruption in the graph of f of c. There are no holes, gaps, or jumps. So here are some illustrations of discontinuity. So take a look of the first figure. So f of c is not defined. For the second figure, so the limit of f of x as x approaches c does not exist. For the third figure, the limit of f of x is not equal to, or the limit of f of x not equal to f of c as x approaches c. So these are the three conditions exist for which the graph of f is not continuous at x equals c. For the removable and non-removable discontinuity, removable, we could write an equivalent function that is continuous. Non-removable, no limit would exist. So the first figure is the illustration of a removable discontinuity. The second one is non-removable discontinuity. And the third one is the removable discontinuity. Now let's have a deeper discussion of continuity. To say a function is continuous at x equals c means that there is no interruption in the graph of f at c. The graph has no holes, gaps, or jumps. So breaking continuity, the function is defined at x equals c. For breaking continuity, so the limit does not exist. A function f is continuous at c if and only if the following are all true. So f of c is defined. The limit f of x as x approaches c exists, and the limit of f of x as x approaches c is equal to f of c. A function is continuous on an interval a, b if it is continuous at each point on the interval. For discontinuity, a function is discontinuous at c if f is defined on a, b containing c except maybe at c, and f is not continuous at c. So two types of discontinuity, the removable discontinuity and non-removable discontinuity. For removable discontinuity, you can factor or cancel out, therefore making it continuous by redefining f of c. For non-removable, you cannot remove or cancel it out. For example, removable discontinuity. So you're doing this. For example, we have f of x equals x squared minus 4 all over x minus 2. So we can factor x squared minus 4 to x minus 2 times x plus 2. X minus 2 will be cancelled. So now you have f of x equals x plus 2. So we remove the x minus 2. So removable. So therefore, we have a removable discontinuity when x minus 2 equals 0 or when x is equal to 2. So 2 cannot be a value of this function because the function will be undefined, right? Or the value will be undefined. For non-removable, let's say we have here f of x equals 1 over x minus 1. So we cannot remove or cancel out this discontinuity. So we have a non-removable discontinuity when x minus 1 equals 0 or when x is equal to 1. So as you can see, if the value of x is 1, the result will be undefined. So 1 must not be a value or domain of this function. So that's why in the graph, it is it looks like a hole, hollow. It means that 1 cannot be a value. For the one-sided limits, you can evaluate limits for the left side or from the right side. So limits from the right, x approaches c from values that are greater than c. So look, let's say we have limit of f of x as x approaches c from the right. Now, if there's a positive there, so c positive, you read it as x approaches c from the right. So it means that c is less than x. Limits from the left, x approaches c from values that are less than c. So as you can see, there's negative there. So you're going to read this as limit of f of x as x approaches c from the left. So for example, find each limit. The limit of the square root of 3 minus x as x approaches 3 from the left. So if we are going to graph square root of 3 minus x, so this will the graph looks like. So now from the left, it means that those values in the left of 3. So as you can see, if we are going to substitute a value which is the left of 3, let's say we have 2, 3 minus 2, that's 1. So there will be a point here. 1, 2, then 2, 1. Okay. Now, but we cannot substitute any value greater than, let's say if we substitute 3, so the result is 0. Okay. But if we're going to substitute, let's say a value which is greater than 3, let's say 4. 3 minus 4, that's negative 1. So that's a complex number. So that's why there are no other points here. If you're going to if the result will be negative. Okay. So another example. So the limit of absolute value of x over x as x approaches 0 from the right. So this will, the graph looks like, so this function, absolute value of x over x. Now, so as you, so from, so 0, so as you can see here, if you're going to substitute a value from the right, the result will be 1. From the left, the result will be negative 1. If we substitute any value. Okay. So here, from the right, so the values will be positive. And then from the left, the values will be negative. So now we have here positive 1 and negative 1. So therefore, the limit as x approaches 0 does not exist because they are not equal. For the limit to exist, they must be equal. So number 3, so example, piecewise function. F of x equals 4 minus x if x is less than 1, and 4x minus x squared if x is greater than or equal to 1. So here, let's say we have the limit of f of x as x approach from the left. So here, so if our value is less than negative 1, so we are going to make use of 4 minus x. So this is the graph of 4 minus x. Okay. Then the limit of x, the limit of f of x as x approaches 1 from the right. So 1 from the right. So x greater than or equal to 1. So this is the graph of 4x minus x squared. Now, so as you can see, if we are going to use values from the left of 1, so here, so let's say we are going to use 1, okay? So 4 minus 1, that's 3. Okay, so that's why it's 3. Then for right of 1, So we're going to use this function. So 4x minus x squared. 4 times 1, that's 4, minus 1 squared, that's 1. 4 minus 1 is also 3. Okay, and then if we're going to evaluate the limit, so using 1, so the result is 3. Okay, so since these two are equal, so we can say that the limit exists. Now let's discuss the steps for solving one-sided limits. So for solving one-sided limits, factor and cancel out as usual. Evaluate the resulting function for the value when x is equal to c. If this answer is not undefined, then that is your solution. If the answer is undefined, then graph the function and look at the graph for when x is equal to c. For example, so the limit of f of x as x approaches 1. So f of x is equal to negative 2x plus 3 when x is less than 1, and x squared when x is greater than or equal to 1. So the function is given, okay? So this is an example of a piecewise function again. So evaluate each function separately for the value when x is equal to c. If the solutions are all the same, that's your limit. If they are not, then the limit does not exist. So if we are going to substitute 1 from the left and 1 from the right, so let us substitute 1. So we're going to make use of negative 2x plus 3. So substitute 1. So negative 2 plus 3, that's equal to 1. So limit of x squared, so 1. So 1 squared is 1. So therefore, the limit as x approaches 1 of f of x equals to 1. So the limit exists. Now, for limits at infinity using horizontal asymptotes. So let's discuss this. So what happens to the graph of f of x as x goes to positive infinity or negative infinity? So what is the behavior of the function f of x is equal to x squared minus 1 all over x squared plus 1 as x gets larger and larger? So take a look of the graph. So since it is a rational function, so the graph will look like this. So as you can see, if the x is getting larger, it is getting closer and closer to y equals 1, but it will not touch y equals 1. So that is the horizontal asymptote. So here, so if negative infinity, that's equal to 1. Positive infinity, that's equal to 1 also. Okay. So for the definition, the line y equals L is called the horizontal asymptote of the curve y equals f of x. If either the limit of f of x is equal to L as x approaches positive infinity, or the limit of f of x equals to L as x approaches negative infinity. So, yan. Okay. So here are some examples of illustration of horizontal asymptotes together with the graph of the function. So let's say we have the limit of arctangent x as x approaches negative infinity and positive infinity. So this will the graph will look like. So to find horizontal asymptotes, so if m is now look at the rational function. If m is greater than n, then no horizontal asymptote and L, so the limit does not exist. If m is greater than n, or if the degree in the numerator is less than the degree of the denominator, then the horizontal asymptote at y equals 0 and L is equal to 0. If m is equal to n, then the horizontal asymptote at y equals a over b and L is equal to a over b. So limit with regard to vertical asymptotes and limit with regard to horizontal asymptotes. Take a look at that. Okay, so now, so for the limit of f of x to negative 1, so as you can see, positive infinity, then limit of 2 from the left, f of x, so negative infinity siya. Yan. Now, what are we going to do if we are going to evaluate limits when it approaches infinity? Okay. So for example, find the limit of 1 over x as x approaches positive infinity. And limit of 1 over x if x approaches negative infinity. Now, class. So the limit of 1 over x as x approaches positive infinity. So 1 over positive infinity. So that is equal to 0. Okay. Then the limit of 1 over x as x approaches negative infinity. So that is equal to 0. So ibig sabihin, kapag in-apply mo yung limit, positive infinity, negative infinity, both will be equal to 0. So we have this theorem. If r is equal to 0, if r greater than 0 is a rational number, then the limit of 1 over x to the r as x approaches positive infinity is equal to 0. If r greater than 0 is rational number such that x to the r is defined for all x, then the limit of 1 over x to the r as x approaches negative infinities is also equal to 0. Okay? So class, ganito yan. So pag ang denominator ay infinity, so di equal to 0 na yun. So example ito. Yan. So the limit of 5 minus 2 over x squared as x approaches positive infinity. So using the previous properties, break the limit into parts. Kasi ito ay example ng difference, di ba? Pwede nating paghiwalayin. So yan, limit ng 5 minus 2. Kasi ito ay sa constant niya, yung k niya. Okay? Tapos limit ng 1 over x squared. Now, ang limit ng constant is the limit itself. No? So since siya ay the limit of 5, so 5 na yung value niya. Tapos 2. Negative 2, bring down nyo lang. So the limit ng 1 over x squared as x approaches positive infinity, so using our theorem, ang value nito class is 0. Ano? Wait lang. Ito. So, ang value niyan ay 0. Ano? So, kaya naging 0 na yan. So, 5 minus 0 is equal to 5. So, the value is 5. Ito naman, using horizontal asymptote properties, so the leading powers are equal. So, equal siya. So, ayun, pwede na nating, ano yung coefficient, di ba, ng 2x ay 2. Coefficient ng x1. So, equals 2 over y. Or 2 over 1. Which is equal to 2. Now, pag in-apply naman class natin yung sa limit, ayan. So, equal siya eh. Kaya, kunin lang natin yung coefficient nung dalawa. Pareho silang first degree. So, 2 over 1. So, that's equal to 2. Ito. Ayan. Third example. The limit of 2x plus 5 all over 3x squared plus 1 as x approaches positive infinity. So, using horizontal asymptote property, so yung top power is less than bottom power. So, as you can see, sa denominator, mas mataas yung degree niya. So, y equals 0. Okay? So, mamaya papakitaan din kayo ng ibang way to solve this. Ito naman, the limit of 2x squared plus 5 all over 3x squared plus 1 as x approaches positive infinity. So, using horizontal asymptote properties, so same lang naman sila. So, kunin niyo yung coefficient 2 over 3. So, y equals 2 over 3. The limit is 2 over 3. So, ito, the limit of 2x cubed plus 5 all over 3x squared plus 1 as x approaches positive infinity. So, yung mas mataas ang degree ng numerator. So, pag ang top power is greater than bottom power, so no horizontal asymptote. So, the limit does not exist. Another way, ito yun, evaluate limit. So, the limit of 3x squared minus x minus 2 over 5x squared plus 4x plus 1 as x approaches positive infinity. So, ang gagawin natin class, tingnan nyo ha, divide the top and bottom by the x with the largest power from the bottom. So, since ang pinakamataas na degree is x squared, ang gawin natin, lahat ng term, i-divide natin by x squared. So, yun, magiging ano siya, the limit of 3x squared minus x minus 2 all over x squared. Galing dito yon yung x squared na yon. So, over 5x squared plus 4x plus 1 over x squared. Ayan. Gets kung ba't nangyari yon? Kung na-gets, click the thumbs up react. Hello, students? Ayan, may nag-thumbs up. Dalawa na. Ayan. Yung largest power, ibig sabihin highest degree. Ano yun? X square. Ano? So, yung x square, i-divide pareho. So, pareho nagka-denominator ng x square. Tapos, simplify natin. Ayan. So, 3x square over x square, that's 3, di ba? Negative x over x square, that's negative 1 over x. Or, in this case, minus 1 over x. Tapos, ito naman, negative 2 over x square, that's minus 2 over x square. So, denominator naman, the 5x squared divided by x squared, that's 5. 4x squared divided by 4x divided by x squared. So that's 4 over x. 1 over x squared. Ayan. Tapos, sa kanya i-apply yung limit. Ayan. Pwede siyang ilimit, di ba? So by our quotient theorem or quotient property on limits. Ayan. Tapos apply niyo yung limit. Ayan. So pinakita lang dito na ayan, inilagay sa lahat. Pero class, pwedeng direct nyo nang i-apply yung limit sa lahat ng terms. So dito pinakita lang na ayan, i-apply sa lahat yung limits. And then, ayan. So limit ng constant. So the constant itself o di 3 tapos dito 5. Tapos ito 1 over x ano, infinity edi 0. Ito 2 over x square infinity edi 0 din. 4 over x infinity 0. 1 over x square infinity 0. So 3 over 5. Nagets, student? Question. Nagets yung process na to? Hello, student. O, react na lang. Na thumbs up kung nagets yung nangyari. O, thank you, Jello. Prince. Patricia. Pretty Joy. Okay. How about the others? Magtanong ha kung saan part mahirap or nalilito. Another example. Yan. So the limit of f of x as x approaches positive infinity sa negative infinity yung gamitin natin. Ayan. So ano yung highest na degree ng bottom? Diba x square? Okay. So we have now f of x equals x to the fourth minus 2x squared plus over 2x squared minus 4x plus 5. So ang highest degree is x squared, di ba? So i-divide natin. Magiging x squared minus 2 plus 3 over x squared. Tapos 2x squared minus 4x plus 5 all over x squared. Magiging ano yan? Ito ay 2. Tapos ito ay minus 4 over x. Ito ay plus 5 over x squared. O, na-gets kung ano yung nangyari? Then, apply natin yung infinity. Okay? So, ito, infinity, x, infinity square. So, since positive infinity siya, positive infinity square, positive infinity pa din. Then, minus 2. Tapos, itong 3 over x squared, pag in-apply natin yung limit, di ba magiging 0? Kaya ito ay positive infinity square minus 2. Sa denominator naman class, di ba, ito yung magiging 2. Ito, pag itong part na to, ito magiging 0. Okay. Itong part na to, magiging 0 din. Di ba? Kaya matitira na lamang is 2. So, class, kapag may infinity na lumabas, kahit ano pa yung mga number na dyan, ang magiging sagot natin is infinity. Okay. So, the limit is positive infinity. Pag negative infinity naman, okay? So negative infinity, so yun, ganun pa rin yung mangyayari, magsisiro pa din to. Kasi kahit negative infinity naman, zero pa rin tong part na to, di ba? So negative infinity square minus 2 over 2. So since negative infinity squared, positive infinity siya. So as you can see, positive infinity pa din. Ayan. Ito naman, another method. So ang i-divide naman natin is yung highest degree ng denominator, which is x over 4. Same given to kanina. So ngayon, meron na tayong f of x equals 2x squared minus 4x plus 5 all over x to the fourth over x to the fourth minus 2x squared plus 3 over x to the fourth. So pag cancel natin yan, magiging, yan, pag pinakita dito na ano, yan, Lahat sila ay may denominator na x to the 4. Tapos simplify isa-isa. So magiging 2 over x square minus 4 over x cube. Ayan. Plus 5 over x to the 4. Tapos yung isa naman, 1 minus 2. So 1 minus 2 over x square plus, dapat ano to, 3. Okay? Anyway, pag ito magiging 0 lahat. Ano? Pag in-evaluate natin using infinity, so that's 0. Ito naman, 0 din, wala nang matitira. 0 over 1. So the limit is 0. If we apply negative infinity, so ayun, same lang din naman. 0 siya. Tapos ito 0 din, 0 over 1, that's 0. Okay? Ito naman, find the limit of f of x as x approaches negative infinity, positive infinity, negative infinity. Our f of x here is negative 3 x squared plus 3 all over 2x squared minus 4x plus 5. Okay? So tingnan natin. So since pareho yung degree nila, kung negative 3 over 2 yung lalabas. 'Di ba? Same degree lang naman eh. Yan. So x, divide natin sa x squared. So magiging negative 3 plus 3 over x squared over 2 minus 4 over x plus 5 over x squared. Ayan. So itong part na to magsi-0. Ito magsi-0 din. So matitira is negative 3 plus 0 over 2 minus 0 plus 0. So yun. Negative 3 over 2 yung lumabas. Okay? So rational functions will have the same limit as positive and negative infinity. But what if not rational? So radical functions can have two horizontal asymptote limits. Ayan. Tingnan natin dito. Kapag siya ay radical function, ano yung gagawin? So the square root of x squared is absolute value of x, which is x. Given that x is greater than or equal to 0. Ayan. So, ang gawin natin, i-divide natin siya by x. Okay? Tingnan niyo yung numerator.
Sir,
Yes.
sir, same po ba yung asymptote tsaka limit?
Sa ano yan? Kasi yung asymptote, di ba, yun yung sa equation, yung hindi niya matatouch, yun yung limit niya.
Opo.
Okay. Now, tingnan niyo to ha. So, 3x minus 2 over x. Ayan. Tapos ang denominator, x din yan. Pero para magpareho siya, ipinakita siya as square root of x square. Pero ang square root of x square, x din naman. Kasi ang x na yung pinakamataas sa degree nito. Kasi yung nasa loob is square root, may radical sign. Kaya mas mataas yung degree na to. Okay? Tuloy natin. Ayan. So, makakancel 3 minus 2 over x. Ayan. Ito class dapat ay nasa loob. Same siya dapat. Same isang radical sign lang to. Anyway, yan. Pakita na natin. 2x squared over x squared plus 1 over x squared. So, ganyan. And then, apply natin yung limit. Okay. So, ito ay Ito siya, ano? Wait lang. Ito muna. Okay? So, 3, tapos ito ay mag-0. O di 3. Ang matitira sa numerator. Sa denominator, ito ay mag-0. So, square root of 2 may iwan. So, 3 over square root of 2. Kapag ito naman, kasi class ang, di ba ang x square, ano siya? Ang square root ng x square, either positive x or negative x. So dito, tinakay natin na positive x. Dito naman, what if negative x yung lalabas? Ano? So kung negative yung x, yan. So negative 3 plus 2 over x. So yun. Ang answer niya is negative 3 over square root of 2. Kasi nga, according to our definition, radical functions can have two horizontal asymptotes or limits. Kaya class, yung isa ay positive, yung isa ay negative. Ito naman. So pag ganyan, yan, conjugates. Kung tandaan nyo pa yung concept ng conjugates, yung i-multiply, sum and difference pattern. Ito, yan, i-multiply natin to. Pareho lang siya. Ito ay, di ba ito ay difference? Kaya ang i-multiply natin na conjugate niya yung sum. Okay? Ito, negative kasi ito. Kaya ito positive. Eh dahil 1 siya, so pareho siya. Pag multiply na natin, so this will be yan, the limit of 1 over, ipakita na nga muna, x square plus 1 minus x square. Ayan. Difference of 2 squares yan. Tapos yun, makakancel ang x square, kaya 1 lang yung matitira. Tapos yun yung denominator. Ayan, apply natin yung limit. Ayun. So ito ay positive infinity square plus 1. Adi yun ay positive infinity. So since may positive infinity dito, so kung ano pa mang value dyan, positive infinity pa din. Tapos 1 over positive infinity. So that is equal to 0. So polynomial functions never have a finite limit at infinity. So left and right hand behaviors. Yan, parang ito. Yan. So negative infinity siya, di ba? Pag positive infinity, positive infinity. Kasi polynomial function siya. So lalabas lagi sa kanila ay either negative infinity or positive infinity. Evaluate. Itry nyo nga to class kung anong lalabas. Itong letter C. Ayan. So the limit of 2x squared minus 4 over x all over x plus 1 as x approaches positive infinity. So ang gawin nyo, i-divide nyo ang bawat terms ng x. Diyan class ay ano, since mas malaki ang degree ng nasa numerator. Kaya nga, 'di ba, based on sa definition natin kanina, does not exist 'yan. Okay? So tingnan lang natin kung makukuha nyo if lalabas sa inyo ay infinity. Thumbs up react lang kapag tapos na. Kahit sa lang yung gawin nyo dyan kasi pareho lang naman yun, positive or negative. Yan. Tapos na si Prince, saka si Samantha. Okay, so ganito yung makukuha nyo dyan, class. Yan. So pag dinivide nyo ng x, so magiging 2x minus 4, tapos 1 plus 1 over x. So yun, yung 2 times infinity, the infinity na yun, minus 4, infinity, 1 plus 0, 1, infinity over 1, positive infinity, okay? So pag negative naman, yun, negative infinity, minus 4, so negative infinity over 1, negative infinity.
Sir,
Okay. Yes.
pag po ba infinity yung limit po does not exist.
Yun yung sinabi, yun yung kanina dun sa part na yung may A greater than B or M greater than N, M less
Sige
than
po.
N, M equals N. Okay, bibigyan ko kayo ng copy ng PowerPoint nito. Tapos mamaya magsesend din ako sa inyo ng picture ng mga theorems. Para pwede siya mabalikan. Mas madaling intindihan ito itong nasa book. Okay, so conjugate. Ayan. Magiging ganito yan. Makakancel ang 9x square. Magiging x over square root of 9x square plus x plus 3x. So, divide natin over x. So, magiging ganyan. Okay. Tapos, apply natin yung limit. Eh, di magiging ano yun? 0. So, 9 plus 3. Ay, square root of 9 plus 3. Ayan. 1 over 6. Okay. So, ito class, basic exponential function has horizontal asymptote at y equals 0. Ayun. Kung makikita nyo, yung sa value, pag habang lumiliit yung value ng x, tingnan nyo yung y. So, lumalaki siya. So, negative infinity. Ito naman, does not exist yan. So, since wala pa naman tayo dito sa trigonometric functions, pinapakita ko lang. Okay. Ito. Ito yung kanina na same sila ng value, di ba? Kaya ang lalabas dyan class is indeterminate. So pag ginawa natin to, i-divide natin pareho ng x square. Ayun. So magiging 0 to, magiging 0. Pag in-apply ang limit, so magiging 3 over 2. Ito naman, ayan. So ginagawa natin to class, ito pwede natin pwede yung method na yon kapag ang mas mataas ang degree ng denominator. Okay, so ang gawin natin, i-divide natin ng x cube lahat ng terms. Diba? Ito ay, ito ano na to, C0. Pag in-apply natin infinity, tapos ito, yun, 0 to. So, matitira yung 0 over 3, that's 0. Ito namang isa, ayan. So, same degree sila. Check natin kung negative 2/3 ang lalabas. Ayan. Dinivide pareho ng x. Ayun. Ito yung kanina, tinatanong ko ba Prince yung nagtanong nun? Ito naman, yan, mas mataas ang degree ng numerator. Ayun. So kapag ang lumabas ay infinity, it means that the limit does not exist. Okay? Ito yung kapag rational. Ayan. So 0, negative 3, then 1, yun, negative 3. Ito naman, so i-divide ng x, may negative 3 plus 1 over x, tapos negative 1 plus 1 over x squared. Yan. Kaya 3, kasi may note naman dito na x is less than 0. Pero pag sinabing x is greater than 0, positive dito. Okay, so techniques for evaluating limits. So use the dividing out technique to evaluate limits of functions. Use the rationalizing technique to evaluate limits of function. Ayan. You can make use of graphing calculators para makita niyo yung behavior ng graph. So evaluate one-sided limits of function, evaluate limits of different quotients from calculus. So in dividing out technique, ito yung ginagamit natin to avoid undefined. Diba? Ayan. So tingnan nyo siya. So 3. Hindi pwede ang direct substitution kasi nga pag negative 3 undefined. Pero kapag less than negative 3, ayan, may value siya na lalabas. As you can see, palapit sila ng palapit sa 5. Di ba? Or sa negative 5. Tingnan natin pag nag-dividing out technique tayo. So the limit of x squared plus x minus 6 all over x plus 3 as x approaches negative 3. So begin by factoring the numerator and dividing out any common factors. In this case, the common factor is x plus 3. Ayan. So the limit of x minus 2 as x approaches negative 3. So simplify, apply the limit, negative 3 over 2 by direct substitution. So the limit is negative 5. So this procedure for evaluating a limit is called the dividing out technique. The validity of this technique stems from the fact that when two functions agree at all but a single number c, they must have identical limit behavior at x equals c. So in the first example, di ba? Ayan. So it agree at all values of x other than x equals negative 3. That's why, yun, nagka-cancel tayo ng common factors. So an expression such as 0 over 0 has no meaning as real number. It is called indeterminate form because you cannot, from the form alone, determine the limit. So kapag may number sa numerator, then over 0, yun yung undefined. Pero pag 0 over 0, ang tawag doon is indeterminate. So sa rationalization, ayan, yun, we are applying the conjugate. So for example, if you encounter something like this one, find the limit of square root of x plus 1 minus 1 over all over x as x approaches 0. So i-rationalize nyo muna, no? Pag direct substitution kasi, yan, lalabas ay indeterminate. Pag nag-rationalize tayo, so let's see. Ang conjugate niya is square root of x plus 1 plus 1. So multiply natin, we're going to get x plus 1 minus 1 over x times square root of x plus 1 plus 1. So x plus 1 minus 1, so makakancel ang 1. Okay, x na lang. Tapos ito, ayan. Pwedeng ito na. Then, yan, makakancel yung x, di ba? Now we have 1 over square root of x plus 1 plus 1. 1 over square root of x plus 1 plus 1. Evaluate the limit. So by direct substitution na yan. So what you're going to get is 1 over square root of 0 plus 1 plus 1. 1 over 1 plus 1. 1 half. Okay. Ayun. Kapag in-sketch yung graph, yan, yung makikita nyo, ganun. So, meron siyang discontinuity. Okay, ito yung kanina, yung sa one-sided limit. Yung from the left at saka from the right. Always remember, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy, and God bless everyone. See you next time in our next lesson.